So here we want to find the fifth derivative for f of x equals cosine of x. Well, let's think about how this would work. If we take the first derivative of cosine of x, we're going to get negative sine of x, right? If we take the second derivative, we're going to get negative cosine of x, since the derivative of sine of x is cosine of x, and we still have that minus sign. What about the third derivative? Well, the third derivative, the derivative of cosine of x, is negative sine x, so we're going to have negative sine of x, which is going to be just sine of x. And the fourth derivative, well, if you take the fourth derivative, then we're going to have the derivative of sine of x, which is cosine of x, which is exactly what we started with, right? So if we take the fifth derivative, we're going to be right back here at the first derivative. So we have 1, 2, 3, 4. If we take the fifth derivative, we're back up here again. So the fifth derivative for this function, cosine of x, is going to be negative sine of x. Now, what happens if we had had a higher power than the fifth power? Well, the way we could figure this out is just by looking at the remainder if we divide by the derivative we want. So for instance, suppose we had wanted the 12th derivative. Well, 12 divided by 4, since we have 4 different things when we take these derivatives, and then it repeats, is going to have a remainder of 0. So that means that the 12th derivative would be the same as we started with, so cosine of x. If we wanted to take the 14th derivative, well, 14 divided by 4 goes into 14 3 times, and we have a remainder of 2. So the 14th derivative will be the same as the second derivative, namely negative cosine of x. So by looking at the remainder, we can figure out where in the pattern we are.